All right, guys, chapter 3, section 4 is zeros, polynomial function. What does it mean if I ask you what the zeros are? The what? Tell me. Solutions, that's one way we can call it. What else? Roots, good. What's another way? X-intercepts. Tell me what that means. What's an x-intercept? I know you guys say that, but what does that mean? Where it crosses the x-axis. Good. Is there another word that I can say? Solutions, roots, x-intercepts, or zeros, right? You're solving for x. If the highest exponent is a 7, how many x's will you have? 7. If the highest exponent is a 4, how many answers or zeros should you have? 4. Are they all going to be real? Not guaranteed. What could they be? Real or imaginary? Good. Okay, so let's talk about the factor theorem. It says if f of x equals 0, then the divisor is a factor. This is where we're going to say, is something a factor of something else? I started to do this a little bit so we could kind of get a little ahead because I have a bunch of examples to do. But if you're asked if something is a factor, you're going to use synthetic division, okay? Some of you are like, why do we use synthetic division? If I gave you this problem right here, and I said, go ahead and factor this, well, you guys would be like, well, I don't know how to, right? If we factor a quadratic, we break it down to 2 binomials. Is this a quadratic? No, what is it? If the highest exponent's a 3, what is it? It's a cubic, good. So if we have 4 terms, what would you try and do to solve this? Group it. If I group first 2 and second 2, is that going to work? No. So we use synthetic division to break your polynomial down to possibly be able to factor it later. So they asked here if x minus 3 or x equals negative 3 is a factor. How? I used synthetic division here. How did I know that it was a factor? Because your remainder is what? 0. When you synthetically divide using a number, whether they give it to you or you figure it out, and your remainder is 0, then that is a factor of the polynomial. Then you have your resulting polynomial. If I start off with x cubed, remember we're dividing, so x goes into x cubed how many times? X squared. Your polynomial always starts your answer with 1 degree less. So I'm left here with a quadratic. We love when we have quadratics because we have 2 options. What can we do with a quadratic? Try to do what first? Factor it. Then if that doesn't work, what do we get to do? We get to do it, right? Because you guys love the quadratic formula? Yes or no? Kinda-ish. Some of you do. All right, so let's see if this factors. I have 6x squared plus x minus 1. A times c is negative 6. What are the factors of negative 6, guys? That'll multiply to give me negative 6, but add to give me, excuse me, a positive 1. So x plus 3 and minus 2. Good. Do I just leave it like that? No, what do I have to do with my 6? I have to divide both terms because my a is not 1. Good. So what does this become? What do we break down to? X plus what? 1/2 and x minus 1/3. Yeah? Now, if you guys want to go from here and solve, you can. You can take the 2, make it a coefficient, and then set equal to 0. Take the 3, make it the coefficient, set equal to 0. Or you could solve it from this point. What are my other 2 answers? X equals negative 1/2 and positive 1/3. All right? So how many answers do I have for this problem? 3. How many did I know from the beginning I was going to have? 3. How come? Because your highest exponent is a 3. Okay? When we use our synthetic division, guys, and your remainder is 0, you have discovered a factor. Don't forget about that. Yes, we came down here and solved and found 2 more answers, but you cannot forget that, oh, wait. When I use synthetic division, my remainder was 0, then that is a factor. Does that make sense? The synthetic division part? The which one? They told you to use synthetic division with negative 3 at the beginning. Okay, here. Well, let's do the next one. I'll do this one with you. 3, 3. Remember, you watched the video, right? Mm-hmm. Did you watch it? Mm-hmm. Okay. All right, let's go over this quickly then. F of x equals 2x cubed minus 3x squared minus 5x plus 6 if x equals 1 is a factor. First of all, I'm trying to find the answers. How many answers, how many zeros, how many solutions do I have? 3. Okay, I know I have 3 because your highest exponent is 3. They're asking you if x minus 1 is a factor. So the first thing we're going to do is we're going to say x minus 1 equals 0. We're going to figure out what we're going to use to synthetically divide. So what number am I going to put up in the corner of my synthetic division? X equals 1. Okay, good. There's your first answer. X equals 1. Okay, here we go. So 1 is a factor if your remainder is what? When we use synthetic division, 1 is a factor if your remainder is what? 0. Okay, so look, let's go over this. You guys should have watched this. I know some of you did. I can tell by what you're saying. Some of you did not, so here's a little quick reminder. When we synthetically divide, we're going to write out the coefficients of each exponent. You have to have a placeholder for each. So since I start with x cubed, I have to have a number for x squared, for x, and for my constant. If there is not a letter, you put what number? If there's not a letter present, what do we put? A 0. You're going to have a placeholder. So the coefficient of x cubed is 2. Coefficient of x squared is negative 3. Coefficient of x is negative 5. And then your constant is 6, correct? All right, so for synthetic division, you bring down the first term. And when we synthetically divide, you multiply to the corner and you add down. So 2 times 1 is 2. When I add down, negative 3 plus 2 is perfect. Do it again. Multiply to the corner. Negative 1 times 1 is negative 1. Add down. Negative 5 and negative 1 is perfect. Multiply to the corner. Negative 6 times 1 is negative 6. Add down. 6 and negative 6 is. So what did you just prove here? X equals 1 is a factor. It worked, quote unquote, works. So now you have the coefficients of your remaining polynomial. If you started off with x cubed, remember, synthetic division, you're dividing. So you're saying x goes into x cubed how many times? So you always start your answer here with 1 less. So this is my x squared, this is my x, this is my constant, and my remainder. So what is my resulting polynomial here? How would I write it? 2x cubed, perfect, minus x, minus 6 equals 0. I now have a quadratic. This is easier for us to work with because we know how to solve quadratics. There's 2 things we can do. You can either try and factor it. If that works, we get really excited. If it doesn't work, we have to use what? Quadratic formula. So let's go ahead. 2 times negative 6 is negative 12. Factors of negative 12. That multiply to give me negative 12, but add to give me negative 1. X plus 4x minus 3, or the other way around? The other way around, good. Watch your signs, guys. Make sure. Take a second to say, does this make sense? I need a negative 12, so that means one factor has to be positive, one negative. And then when I add, my middle term needs to be negative. So your bigger number gets the negative sign. What's one thing I have to do before I go ahead and set equal to 0? Divide both by 2. So this becomes x minus 2 and x plus 3 over 2 equals 0. So what are my other 2 answers, my other 2 roots, my other 2 solutions, my other 2 x-intercepts? 2 and negative 3 over 2. Perfect. Good job, guys. Does that make sense? All right, good. All right, I may not do every single example here. I'm going to skip this one. If we have time at the end, I'll come back to it. But what are they asking here? Factor this beautiful polynomial and see if what? If negative 5, quote unquote, works. How do you know it works? Your remainder would be 0. Then you can factor the resulting. Okay, let's go on to the meat of this lesson. All right, we're going to do something called the factor theorem. I'm going to refer to it as P over Q. All right, to find all of the possible roots, this is going to lead us into why we need to be proficient with our calculator. You want to put your polynomial in order of decreasing degree. What does that mean? What does that mean? If you put your polynomial in decreasing degree order. The highest exponent goes where? first, and then they go down in order. Good. You're going to find the possible roots. It's going to be plus minus. You'll see what I mean by this in a second. The last term, which is your P, over the first term, which is your Q. To find all the roots, you have to test the possibles until you find a 0 that gives you a remainder of 0. To find an answer that you get a remainder of 0. Again, let's look at this. Hold on. Don't look at this. We'll start out from the beginning. If I said to you guys, factor this, what are the answers? We're going to set this equal to what? 0. The first thing you should do is say, okay, is there a GCF? No. There's 4 terms, so can I group it? Is grouping going to work? No. So up until this point, you guys would go, I don't know what to do. I can't figure it out. I don't know. We don't have a method. This is where P over Q comes from. All right, P over Q. Let's list out all of our possibilities. I have my P and I have my Q. P is which term, the first or the last? God bless you. P is your last, so go ahead and write that out. Q is your first. Now on WebAssign, when they ask you to list all the possibilities, you have to do this separately. I'll show you what I mean in a second. What are the factors of the last term? What times what gives me 15? Don't worry that it's negative. We'll account for that in a second. And what else? Okay, so 3, 5, 15, and 1. Now, do you guys know off the top of your head if they're positive or negative? You can look at this and tell me if it's positive 1 or negative 1. You don't. So we have to account for plus minus of each of these. If you want to just put plus minus in the front and list out your factors, that's fine. So how many possibilities do we have there? 8. Why is there 8? Because it's plus or minus. Good. Now we have to take into account our first term. Well, what's the first term of our equation? 8. So it's plus minus 1, 2, 4, and 8, correct? If you want to put plus minus in front of each one, that's fine. If you want to put plus minus at just the beginning, that's fine as well. All right, so we listed that out. Guys, there's some more possibilities in here that we don't see. Because this P over Q actually accounts for all of your whole numbers, and then you have to take your P term and put it over all the Q's, each one. So I also have to say it could be plus minus 1/2, plus minus what? 1/4, plus minus 1/8, then what? Plus minus 3 over 2, plus minus 3 over 4, plus minus 3 over 8. Ay, ay, ay. Seriously? Then what? Plus minus 5 over 2, plus minus 5 over 4, plus minus 5 over 8. Then what? Because we already have the whole numbers accounted for. So 15 over 2. Do I have to do 15 over 3? No, we already have it. 15 over 4, 15 over 8, all plus minus. So what, in a sense, you would have to do here, I'm setting this up to show you why you need to be proficient with the calculator. In order to prove or to find a 0, you have to use synthetic division, correct? You would have to use synthetic division with all of these to find where the first one gave you a remainder of 0. Now, you could be lucky and it happens to be positive 1. Or it could be where all of them are fractions and it takes you 25, 30 minutes just to find one. If we're doing a calculator portion, do you think it's going to work out that it's the first whole number that you try? Probably not, okay? So tomorrow, we're going to learn how to put this into the calculator from the get-go, find the whole number that is the 0, use that for synthetic division, and then discover the ones that are fractions. So let me go ahead and tell you, the whole number that works is -5. If I did not tell you from the beginning, you guys would have had to do 1, -1, 3, -3. Some of you would get frustrated and say, okay, fine, I'm going to try 15. I'm going to try negative whatever. This is not to frustrate you. This is to show you the importance of being able to use your graphing calculators. Some of you guys have a $120 calculator that all you know how to do is add, subtract, multiply, and divide. It does so many things, but we have to learn how to use it. And it'll be really effective for you when you're taking your SATs. So let's go ahead and synthetically divide with -5, since I already told you one of the answers. So tell me my coefficients. 8, what else? Positive 50, right? Then what? -15. Now, if this is a root, this is a 0, this is a place that it crosses the x-axis, what should my remainder be? 0, okay? So let's bring down our 8 and then start our synthetic division party. 8 times -5 is -40, okay? We're going to add down and get, perfect. Multiply to the corner, 10 times -5, -50, good. 47 and -50, -3, good. Remember, our negatives are important. What's -3 times a -5? 15. What's -15 positive 15? Woo! We like when our remainder is 0 because we just said that x equals -5. Because our remainder is 0, the -5 is a solution. So now I have leftovers. I have 2 more zeros that I need to quote-unquote discover, right? There's 2 more hidden in there. What is left over with 8, 10, and -3? 8x squared, what? Plus 10x minus 3 equals 0. And then what do I do with that? Well, hopefully, we hope and pray that this does what? That it factors. -24. Factors of -24, that give me a -24 when I multiply, but a positive 10 when I add. X plus 12, x minus 2, perfect. Divide both by, you guys are brilliant. So x plus what? 3/2? And x minus 1/4? So what are my other 2 x's that I discovered? -3/2 and 1/4. Perfect. Do you guys see the importance of being able to use your calculator? Yeah? All right, we're going to do a couple more. How are you? All right, if we're going to list all the possibles for 5, I'm not going to do 5. It's long. If you want me to do it later, I can. Actually, you know what? I'll come back to 5 at the end. All right, let's look at number 6. Did I skip 5? Yeah. Do it at the end. Let's look at number 6. All right, why is this one a little bit easier? What's your P term? What's the last term? 5, right? You don't have to worry that it's negative because we're going to count for. So what are all the factors of 5? So plus minus 1, plus minus 5. Q. What is my Q? 1. So we really only have 4 different factors to try here, right? Positive 1, -1, positive 5, -5. The coefficient of the first term. So when you have a coefficient of the first term and a constant, it makes your list of possibilities so much longer. That's why our calculator is so important. In this case, it's not really that big of a deal. We're going to use synthetic division to figure out what one of the zeros is because this is not a quadratic. Yes, there's 3 terms, but I can't just break this down into 2 binomials. What times what's going to give me x cubed? It's not going to work that way. I can't use the quadratic formula. So let's use synthetic division. Let's just try 1. If 1 works, great. If it doesn't, we'll try -1. You just keep trying until you find your remainder of 0. So what are my coefficients, guys? I'm going to write out. 1, 4, 1, 4, y, 0. Miss Lyons, you are correct. You have to account for every single exponent. If I start with x cubed, I have a place for x cubed, a place for x squared, a place for x, and a place for my constant. If something does not exist, you have to have a placeholder. Everybody with me? Okay, so let's do our synthetic division. This is easy now. Multiply to the corner. 1 times 1 is 1. 4 plus 1 is 5 times 1 is 5, right? 0 plus 5 is 5. 5 times 1 is 5. -5 and 5 is. So what'd you guys just prove to me? 1 works. X equals 1. That's one of my zeros. So what is left over? X squared plus 5x plus 5 equals 0. I have a quadratic. So we hope at this point that this factors. If it doesn't, what do we use? Quadratic formula, okay? Are there factors of 5 that'll multiply to give you 5 and add to give you 5? It'll give us 6, but it won't give me 5 when I add. So I have to use the quadratic formula. Negative 5 plus minus. What's your B term? 5 squared minus 4 times A times C all over 2 times 1. You guys agree? All right, now it's just basic. Negative 5 plus minus 25, not 250, 25 minus 20, right? Over 2. So I have negative 5 plus minus the square root of 5 over 2. All right, is that 2 more solutions? Yeah, it's negative 5 plus root 5 over 2 and negative 5 minus root 5 over 2. So here's my other 2 solutions. Are they real? Yeah. Are they pretty? No, but they're real. That's fine. So you found your 3 solutions. So again, let's look at the next one. Can I factor this? No. If it was x squared, yeah, but it's not. It's x cubed. This is not a quadratic. So I have to do my p, which is my last term, over q, which is my first term. What are the factors of 3, guys? So I have plus minus 1 and plus minus 3. Let's see what works and what doesn't. If I always start with 1. If 1 doesn't work, I go to negative 1. Then I go to 3, then I go negative 3. If you guys want to jump around, that's up to you. I just don't think that's a good idea. So let's try 1. Does 1 work? So what are your coefficients? 1, 0, 2, negative 3. Why did you put a 0 for that second number? Because there's no x squared. Perfect. So bring down your 1. 1 times 1 is 0 plus 1 is perfect. 1 times 1 is 2 plus 1 is 3 times 1 is negative 3 and 3 is woohoo. So what's one of your answers? X equals 1. Your remainder is 0, meaning whatever you use to synthetically divide is an answer. So what am I left over? 113. X squared plus x plus 3 equals 0. Try to factor it. Are there factors of positive 3 that multiply to give me 3 but add to give me 1? No. So I have my quadratic formula. Negative 1 plus minus the square root. 1 squared minus 4 times a, which is 1, times c, all over 2 times 1. Everybody agree? Okay. So negative 1 plus minus 1 minus 12 all over 2. Yep. So negative 1 plus minus the square root of negative 11 over 2. So how do I write this? Negative 1 plus minus what? I root 11 over 2. Give me 1 second. Are those 2 other answers? Yeah, those are 2 other answers. Now, here is how this question could be asked that could be confusing. If I said to you, what are all of the solutions? You would tell me it's 1, and then negative 1 plus minus I root 11 over 2, correct? If I said to you, what are the x-intercepts? You would tell me what? X equals 1. How many x-intercepts does this graph have? 1. It has 3 solutions, but 2 of them are what? They're imaginary. Good, go ahead. All right, let me do the last one and let you guys work. Find all of the what? Zeros. Well, first of all, I tell myself, how many do I know I have? 5. I have 5 answers in here. Are they all real? No. But there's 5. So if I said to you guys 20 minutes ago before we started this, okay, how do you guys solve this? You'd be like, I don't know. But now we know. How do we solve this if it's more than 4 terms that doesn't group, it's not a quadratic, what do? We do synthetic division. We do P over what? Q. We love the fact, guys, that your first term has a 1 as a coefficient, because then it's not as hard. What are the factors that I have to try? 1 plus minus 2 plus minus 4 plus minus 8. You guys with me? All right, so let's just start with 1. Hopefully 1 works. So I start with 1. What are my coefficients? 1. Good. Why is it 0? Perfect. 1, 0. 1, 2, negative 12 and positive 8. Perfect. Multiply to the corner, add down. 1 times 1 is 0 plus 1 is 1. 1 times 1 is 1. 1 plus 1 is perfect. 2 times 1 is 2 plus 2 is 4 times 1 is negative 12 and 4 is negative 8. Negative 8 and 1 is 8 and negative 8 is? All right, what did you just prove to me? X equals 1 is a solution. Perfect. Now, what is left over here? X to the 4th plus minus equals. Okay, all right, so now can we group it and go ahead and go? Oh no, it's too big. What do you think we have to do again? Synthetic division. We're going to do P over Q again. When you have X to the 5th, you're probably going to have to do synthetic division twice. So again, your P term, your last one, plus minus 1, plus minus 2, plus minus 3, just kidding, plus minus 4, and plus minus 8. Your Q is just 1. Now, guys, you'll see why it's good to know how to do this in your calculator. I'm going to start with 1 and see if 1 works. So what are my coefficients of this? This is what we're working with now. 1, 1, 2, 4, negative 8, okay? So bring down 1. Multiply to the corner. 1 times 1 is, and 1 plus 1 is, 2 times 1 is, 2 plus 2 is, 4 times 1 is, 4 plus 4 is, 8 times 1 is, negative 8 and positive 8 is. What did you guys just prove to me? 1's a solution again. What does that mean when we have 2 of the same answers? Multiplicity. Very good. Does anybody remember what that does on your graph if you have multiplicity twice? It bounces. Very good. It's going to touch that point and go the other way. Very good. So I uncovered now 2 answers. How many more are still missing? 3. So let's write our resulting polynomial. What's left over with this 1, 2, 4, 8 nonsense? X cubed plus 2x squared plus 4x plus 8 equals what? 0. All right. All right, I have 4 terms. Should I just go ahead and do synthetic division again? You can group it. Guys, always try the path of least resistance. If we have 4 terms, not all the times it's going to work to group, but just check. Just say, look, if I take the first 2 and the second 2, will this group? What can I take out of x cubed and x squared? X squared, and I'm left with what? X plus 2. Okay. What can I take out of a positive 4 and a positive 8? Plus 4, and I'm left with what? X plus 2. Oh, good. Always check. Check when you have 4 terms if it'll group, and check if you have 3 terms if it'll factor. So now that we've discovered our new GCF here, I take it out 1 time, x plus 2 in the front, and then what happens with my leftovers? I have x squared. All right, so now, can I factor x squared plus 4? Can I factor x squared minus 4? Yes. X squared plus is going to give us good. Some of you guys saw that imaginary. So here I'm going to say x plus 2 equals 0, and x squared plus 4 equals 0. So here I have an answer of x equals negative 2, and here I have an answer of x equals what? Plus minus 2i. Do I now have all 5 of my answers? Yes, I have 1, 2 times. You guys see that? How many real answers do I have? 3. How many imaginary? 2. So I have a total of 5 solutions. I have a total of 5 roots. How many x-intercepts do I have? 3. How come I only have 3? 2 of them are what? Imaginary. All right, so this, guys, is you're going to have a portion of your test where it's going to be an x to the 4th, an x to the 5th. You have to find all the roots. You're going to have to use synthetic division, P over Q. But you're also going to have a section of the test that's here. Use your calculator. You're going to have to be able to do all this in your calculator. The next 3 days, that's what we're going to be practicing. I'm going to show you guys how to find the left bound, the right bound. We're going to zoom in on stuff. We're going to find the intercepts, all of that good stuff. So you have to have your calculator tomorrow. Everybody with me? All right, good job. Guys, one more thing I want to say. Make sure I say it on the video. There is no sharing of calculators. So the day of the test, if you come in and I forgot mine, you're going to have to run somewhere and get from somebody else, but you cannot wait until your friend turns theirs in and then use their calculator. No sharing of calculators, okay?